So hello guys, welcome to the first episode of this rocket propulsion series. I'm Quantum AI and now let's start the video. In this video we're gonna look at how many propulsion systems are there in the market. Many propulsion systems are there. And first of all, what is a propulsion? You see some material is getting ejected out here. This is propulsion. To go rocket, like rocket wants to go upward, so using Newton's third law of motion, it ejects some material downward. So that is called rocket propulsion. Now we're gonna look at it in a very deep manner. Hmm. So what is a rocket? It produces thrust by ejecting matter. It is ejecting matter. Some eject air, some eject for solid fuel, some eject hydrogen, some eject light, some reflect light. Many kind of things are there. Many kind of names these things have. These are the things of hope of humanity. Rockets are the hope of humanity to escape to the solar system, to escape to the another planet in case of anything happens to the Earth. These are hope. These things are the hope of humanity. That's why Elon Musk is mad at it. But there is a hope of humanity, and let's start. So see, these many things are we gonna study in this video. See, are you saying turbocharged engine, ramjet engine, solar engine, solid engine, solar cell engine, electric engine, electron ion engine, chemical engine, nuclear engine. We're gonna study all this in this video. So let's start without a delay because time is important. So first of all, we're gonna study about two terms, propellant and energy source. So, what is propellant? Propellant is the material that is physically ejected from the propulsion system. Propulsion system means rocket. So, propellant is material that is being ejected to generate thrust. Newton's third law of motion. Sometimes it is hydrogen, sometimes it is air, mm, sometimes it is xenon gas, sometimes it is stored solid fuel, sometimes it's helium also. Many things are there. What is energy source? Energy source is the source of energy that heats the propellant or provide energy to the propellant. Energy's work of energy source is to provide energy to the propellant so that propellant can exit the knowledge at the high speed so that rocket can get high speeds. To eject the propellant, we need to eject the propellant at high speeds. We need energy source to heat the propellant to pour the energy in the propellant, and we use various kinds of energies, chemical energies, nuclear energy, solar energy, electrical energy. We use very kind of energy source in the rockets. Now let's look at one by one. Turbojet. Turbojet. What is the propellant? Or like what is going to be ejected out of the turbojet? Air. So air will come and air will go. Okay. And what will provide energy to the air so that it can exit at high speeds? Some fuel. It fuel will be chemical. So what happens? Compressor is sucking up the air, and here what happens? Fuel injection will happen, and this turbine is like exiting. Like this turbine is helping the air to go out, and also helping this compressor to suck the air. So main point of this air is like air is drawn into the engine, compressed, mixed with fuel, and then ejected at very high speeds. Compressor in, fuel mix, go out, and in that process just rotate some turbine also so that the exhaust or energy of that high speed air can be reused, so it can go a compressor. Examples of use where it is used: F-16 Falcon. I know you Boeing 707. Many, yeah, like commercial planes, commercial jet fighters. It is used there. Okay. Turbojet engine. Now let's move to next. Ramjet. What is the difference between this ramjet and turbojet? Only difference is there are no moving parts like compressors. Hmm? Here, air is sucking. It is try to suck the air and then eject, then mix the fuel, then get out the air. Okay. Here, what happens? Ramjet engine needs to be like first give us like a very slow speed. So, engine is already traveling at a sonic speed. So, because it is used in missiles, like it is used in BrahMos missile. So in ramjet engine. So what happens? Engine is already traveling at a very high speed. So air will come automatically and we will mix the fuel and it will go. No need of turbine and compressor. This can start from zero speed. This has to be at sonic level. Then only it will go at supersonic level. So what happens generally in BrahMos missiles, missiles which go supersonic? What happens? First this engine is fired, then this engine is fired. So though the combination is turbo ramjet. And the fuel here is used hydrocarbon fuel. It's a very high power fuel. Okay, this is used in missiles, turbo ramjet missiles, missiles, missiles. Rockets. Now let's really talk about rockets. First two were some. First two were like some planes, missiles. Now rockets will start. Here the propellant is stored propellant. See, in rockets will go in space, so no air is available. So you cannot suck air as a propellant and throw air as a propellant. So you need to store the propellant inside the rocket only, and you need to heat up the propellant so that it can be ejected at very high speeds. So the thing is, energy source is this fuel tank, okay, and propellant is this oxidizer tank. So what happens? This goes here, and this goes mixer, and then combustion chamber, then boom. Okay, so there are like two tanks, and this tank, what is the main problem in this whole system of these rockets? Maintaining the temperature. See, oxidizer tank has to maintain at some temperature, fuel tank has to maintain some temperature, then they got to be mixed in the combustion chamber, then they have to be ejected, and these are heat exchanger, gas generators, oxidizer pump is basically to suck and to suck this, to suck fuel and oxidizer, and turbines and all that there. And where it is used, Falcon 9, space shuttles, Apollo missions. This is the main rocket. This is where business of rocket lies. Chemical engines, chemical rocket engines. You know why it is used? Because it is safe also. Because when rocket blasts, this fuels does not like pollute air and all that. Because fuel is in liquid form. You know that kind of thing. This rocket is very safe even if it blasts. That's why they use it in Falcon 9 and all these things. Mm. So the main point of this, there will be oxidizer tank, there will be fuel tank. It will come through pumps and get mixed here, and these all things are just there to maintain temperature. They eject at very high speeds. We will talk about speeds in next episode. What speeds? Ducted rocket, air augmented rocket. Whenever you see NASA missions, they have a big orange rocket in the middle and some yeah what some small white rockets. You know these all are this. These are boosters. Solid rockets, the solid fuel rockets are used in boosters to boost the rocket because it burns so fast. Fuel is also available so much and it burns so fast, so it is used as booster. Interballistic, intercontinental missiles, and so rocket boosters. And what is the energy source? Some stored solid fuel is stored. See, this is stored solid fuels, and surrounding air is also. Sorry, surrounding air is used. Oh, surrounding air is used. Some solid fuel is also used as energy. So, in solid energy source, solid propellant. Everything is solid. Fuel rich solid propellant. So let's see the Works by burning a fuel-rich solid propellant and exhaust gases are mixed with air to create additional thrust. Okay, so this works like this will be ignite. Okay, this is igniter. This is solid fuel, and this is insulator. This black thing. This will get burn, 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 and this will there is air. So here is air. Okay, here is air. So this energy is coming from the fuel. So here is air. So it will propel very fast. It will like boom there, boom there. So now for the burning fuel, its solid propellant and exhaust gases are mixed. Okay, solid rockets, boosters. Now the interesting part of the video: electric rockets. Electric rockets. You know where it is used? It is the technology of future. Electric rockets, ion propulsion systems. It is used in deep space. And what is the future? Deep space. So that's why it is. This is and this will be studied in so many places. So what happens? See what happens. We ionize the gases. We ionize the gases, and ions can move at a very high speed in some electric fields or magnetic fields. Okay, if you put if you put an ion in an electric field, it will move very fast according to the acceleration provided by electric fields. Um, so what happens? Like a power unit is there. Okay, a power unit is there. See, let's use this diagram. Huh. See, helium coupler ionides the propellant. Superconductor generates magnetic field that confines the plasma. So, and thrust generated as plasma escape the magnetic confinement. So this is this is propellant, neutral gas. Xenon is a neutral gas. Xenon is stored here. It comes here. A helium coupler is there, which ionizes the xenon. Now it is ionized, so now it has charge. So superconductor generates a magnetic field. So in magnetic field, ions move at a very high speed. Same used in Large Hadron Collider also. At magnetic fields, ions move very fast. So if the ions speed increase, it escapes at very high speeds. Okay, and the temperature is so high because plasma forms, so whatever temperature is so high, so temperature problem is there in rockets every time. And as I say, like it is used in deep space missions, like some satellite is going to where Saturn, where Alpha Centauri, that will use this. Now the banned one, this rocket is banned. Okay, know why? Because this is so powerful and so problematic. Nuclear rockets. It was last developed in 1960s, and this type of engine is highly efficient and suitable for long duration of space travel. But this engine is most powerful engine, nuclear rocket engine. Okay, and how it works? See, it uses inside the rocket a nuclear reaction is happening. Okay, and that nuclear reaction releases heat, like heat released in Nagasaki bomb. Okay, so using that heat, we what heat the liquid hydrogen so that it will come to gaseous form again. Because liquid hydrogen, if you liquid hydrogen, if you heat it, it will become gaseous again, and that gas will be ejected at very high speeds. So the energy source is this reactor. It is releasing the heat, and the propellant which is ejected out is hydrogen. Problem is this: if rocket blasts, nuclear energy will be spread, nuclear waste will be spread here and there, and whole earth will go mad. Okay, so that's why this is banned. But yeah, as you can see, suitable for long duration space travel. Means nuclear Elon Musk will use this. I can bet on it. He is using it now. Long duration space travel. He wants it, right? Now solar heated rockets. This is a very weird rocket. What happens? There is some propellant, hydrogen. It uses sunlight, concentrate the sunlight and heat the hydrogen, so it will become normal gas again, and it will escape the nozzle at very high speeds. And how this high speed is achieved will be the topic of next video or next to next video. For now, just some propellant is there, and in this area it is using this energy, it is gaining high speeds and getting ejected out. I will repeat again, some propellant is there for every rocket. This is fine. Some propellant is there, some energy source is there. Eh, During near this nozzle area, this propellant is getting heated up using that energy source, and it is get expelled out at very high speeds. Okay, photon rocket. This is very weird thing. Like a bulb is attached at the back of rocket, and bulb or laser ejection. So there is no stored propellant. So very powerful laser is attached to the back of rocket, and so the photons are ejecting. So propellant is photon air. Like using light, we can go deep into space. Thrust is very minimal because you are ejecting light. How much thrust you can produce? Just hold a torch and on it. So will you feel any thrust? No, na. You will feel, but very less. So it is using that technology. It is ejecting light, not air, not hydrogen, not some liquid fuel. Wow. And this is solid cell, solar cell, sorry, solar cell. Hmm. Energy source, solar radiation. Propellant working fluid, non-photon reflection. How it works? A solar cell works by reflecting photons from sunlight. It is very weird. See what happens. This is a sail, right? This black part is sail. What happens? Sunlight, and initially the sail was going in this orbit. Okay, this one. What happens? Sunlight reflects. Sunlight comes from here, and due to reflection, it goes there. When it reflects, na, it sunlight like mirror. Sunlight puts a pressure in the on the sail. Sunlight puts a pressure on the sail. Sail tilts, and it goes into new orbit. But thrust force is generated using sunlight here. See, sunlight here and there here. Suppose imagine a ball striking here. If a ball strikes here, it will tilt in that direction, this sail, right? Obviously due to Newton's law. But there is no ball here. There is plain sunlight. Plain sunlight. Where it is used. This is actually demonstrating technology. This is not used currently as of so, but it is demonstrating, like it is in development. It is in development. Okay, so we have reached the end of the video. We have looked so many things in the video. Okay, turbojet, ramjet. So this is for planes, this is for missiles, this is for Falcon 9, this is for boosters, this is for deep space missions, this is banned actually. It, this when this is not getting banned, the real way fun will start. This is solar heat, I don't know where it is used. This is laser rockets, this is solar sails. So some propellant is there, some energy source is there, and that energy source is heating the propellant, and somehow it is getting ejected at very high speeds using the nozzle mechanism and all that. Okay, this is all about all propulsion systems, and we gonna cover every propulsion system in detail in next videos of this series. So stay tuned, guys. Sayonara, bye bye.